Well, I mean, you could
Not just
programmatically build
program,
your
you basically the
interfaces
storyboard.
by just adding subviews. I mean, you could just avoid ever using storyboards. You could programmatically create a UI view with a frame and add it as a subview to another UI view, like literally never using drag and drop stuff.
Okay. Good. That would be hard and annoying though.
It's what Uber
How
does.
easy-
Uber's iOS app does. That's all they do is programmatically build their interface.
I mean, I guess once you do it over time, it'd be fine, but initially they would be.
Uber doesn't really have that much interface, does it? It's pretty.
Yeah, I guess not like horribly complex, but point is that they don't want to rely on their on Apple's auto scaling and auto sizing stuff. So iOS, what's this?
It's like, oh, can't blame them.
No, I mean there's some truth to that. I mean it's constantly playing this fighting battle where if you want something to look right on one device, it breaks on two other ones, and then you have to learn the interesting way or kind of you have to learn the way to use auto layout in such a way that it works. And their button that just says make our best guess is often not the right way. You got to do like two steps in a way that kind of stages things in such a way that their add missing constraints button does what it's supposed to do, as opposed to does what half of what it should do and then a third of what it shouldn't have done. All right, so let's see here. So homework was to have our server be able to take multiple incoming connections. Every time we have an incoming connection, we spawn a child process off, right? And then the server goes back to listening. So we should have a whole bunch of child processes, each one being able to have constant communication. So we're going to do this in a couple of segments. We're going to start off by having our server go ahead and fork a child process for dealing with a client that just connected. And then we're going to do basically a back and forth chatter with that child process and the client socket. Once we have that working, where we can have 2 or 3 clients connect, each one having their own child process dealing with their incoming chats and just basically sending it right back to them, just echoing it back over their one socket. Then we'll integrate those children with inter-process communication to talk to other things. Okay, so we're going to go ahead and we're going to have our server. I really wish I could figure out how this thing is just not highlighted. That's just stupid. Like, and it changes like while I'm sitting here doing things. Like it'll like get half highlighted and then unhighlighted. And
Apparently you can disable it via preferences.
I thought I've looked for it.
Why would you not want to see the collaborators of your?
Well, I don't care if I see the collaborators. I just
The
don't.
tweak is you can disable it via highlighting via the preferences, but why would you not want to see the cursors of your collaborators?
So where is it in preferences here? Show notification bubbles. That doesn't sound like something I want.
Highlight. No, that's not it.
Yeah, this is like we're way past. Collaboration was just this one little portion here.
You need to tweet out your support because it's.
dude who was tweeting about it.
Oh, somebody else
A
was.
teacher was having the exact same problem as you, and they said just check preferences.
Oh, that was like their thing. Just check preferences, not like specifically.
Nope. They said you should be able to in preferences.
You're right. You should be able to. It's like, all right. It's maybe under experimental. Project settings. All right. Maybe this is the issue. All right, it's not highlighted now. I have a feeling.
Well, it's the cursors are still there.
I'm less concerned about those. I just don't like when it gets completely highlighted like that. Okay, so who did that?
Me. Still works.
Okay, man, that's just ridiculous. So I'm the only one that's right. I thought maybe switching people over to read only. All right, well, whatever. All right, so we're going to go ahead and get everything moved into some functions and stuff so we can. So right now we have our broadcast that I think is working, but we also want to move just the ability to send a single message to a client to simplify things. So var send. Let's do send message. This will be char pointer message. It's going to take an int client that we're sending the message to, and then we'll go ahead and steal this code, and we're going to send our message to client like that. So just a convenience function for sending a message. Good enough. Okay, so now let's go and start forking some children, Abe. All right, so let's do. This is binding. All right, so there's our accept. So we're doing this indefinitely right now, and every single time a new connection comes in, we're going to go ahead and spawn off a child.
On your URL, add question mark collab equals 0.
Equals 0.
Deleted. All right, people highlight.
Nice.
Blessed be Stack Overflow.
Okay, so we need to do. Let's see, how are we going to pull this off? So we're going to accept a single incoming connection. I'm going to take our infinite loop out for a moment here. And we're going to go ahead and, oh, that needs to go in still. This is the closing for the infinite loop. So we're going to go ahead and have a void listen function. And listen is going to take in a sock. Call this guy sock FD. And ultimately, this guy is going to return an int. This guy down here. And let's see, we have our sock address, and have we made those guys global? I want to move some of those up to the top. Let me move. Oh, did it?
Yeah.
Is that good or bad?
Mine's gonna be bad.
Now I need to actually watch the screen.
What happens if you save it? Oh,
Oh,
there.
there we go.
Just
Opted.
save it.
So if save often, it should.
Yeah.
Okay, so I put send message up there. So what I'm doing is I'm trying to move things into some modules so that we can more easily call stuff here moving forward. When we listen, we're going to have a incoming connection, and then we need to have access to our server and server size. And that guy is set up here. So I'm going to go ahead and move this guy outside of here. I think we should be able to create a variable up there. We're going to leave. Similarly, we want this guy up there. All right, all this stuff can happen in here. That's our socket setup stuff. In fact, actually, we could get that out of here as well, because server is up top. So we can do void setup server socket. And this guy is going to do we're going to have our int sock fd up there. I'm going to take all of that stuff, drop it in here. We're going to move this guy up here. Get that out of there. Here's our bind. And this guy's actually our error message, not our bind FD. Okay, so far so good. So all right, so there's our binding. I'm gonna check something here real quick. Okay, we only need to do that once. So this listen thing only has to happen one time. So I'm just going to do that since we're not actually, actually this is going to be a, I believe, just an error message. Zero's returned, yeah, that's just an error message. So we can get back to just that guy. So we'll put our socket into listening mode down here. Just reusing the same error message. Okay, that's set up server socket. And then we're going to go ahead and have a function. I didn't start writing it yet. Yeah, I did. Called listen. Here's the accept. All right, so this guy. Actually, we can leave that up in the server, up in the main. So we'll take listen out of here. We need to move this guy up to the prototypes. So we have setup, broadcast, send message, broadcast, send message, setup. Okay, they're prototyped. Then we have a couple of global variables that are being used inside of our setup, as well as in our accept here. So that's why we needed those to be global or something. All right, and listen FD, we don't use that anymore. Client FD we do, max clients we do for that. Okay. So here's our incoming connection. We add it to our connections, then we broadcast to everybody currently. I'm going to actually do a send. Well, let's just make sure this still works for right now. So when somebody connects, we're going to broadcast our message to them, hello, to all the clients, and we're updating clients here. And then we should, for right now, then we can just go ahead and rewrap this. I won't do any indenting stuff. I'm just going to rewrap it in our while loop because we're going to go back to this. Okay, so let's make sure this new stuff we just didn't break stuff, and let's make sure we kill off our clients. Okay, so now we can kill our server, recompile it. Oh, it wants me to make that a const. Okay. See, in order to initialize that up there, it has to be a constant, which means that I need to do this. Steal that here. Oh. Go ahead and set server equal to that. Oh no. I need an old priest and a young priest. Oh, I never actually call my setup socket server. So, kind of important. I moved all that code down there and never called it. So let's set up the socket server. Then we should be able to actually accept. All right, so he's listening. He got the hello. He got the hello. This guy got hello again. Seems to be still working, even though we've compartmentalized stuff around. All right, so now let's kill off the clients before we kill off the server, and we'll go do some more work on the server, kind of staging it for our next step of our app. All right, so right now we have a single incoming connection called client FD, and this is when we want to actually fork. We want to split. But what we're going to do is we're going to, so let's do it this way. So we have a variable called client FD currently, and we can go ahead and do the fork system call. So we'll add him to our list. We're not going to share it yet, but we do want to go ahead and spin off a child. So we'll do and PID is equal to fork. All right, so we're going to come out of this and we're going to either be the parent or the child. Now, if we're the parent, what do we want to do? We want to go back and listen for another incoming connection. If we're the child, what do we want to do? Well, for the child, we want to start maintaining a back and forth communication channel with this child connected socket. Right now we have this guy inside of an infinite loop. Actually, let's go this route. We'll leave it there for a second. We're going to do call this child stuff. All right, and for right now, let's just do printf child stuff \n like that. All right, so we have our incoming connection. Oh, missed the. There we go. Now, what is it? If the PID is 0, we're the child. PID is other than 0, then we're the parent because we got the process ID of the child. So if PID is equal to 0, then we're going to go ahead and call child stuff.
Forking and then you're doing child stuff.
We make sure the parent doesn't get in there, so it should be okay.
Now the parent's still in an infinite loop, so they're not going to let him out of their grasp at this point. At this point, things are fairly locked down. I don't even know what that means, but it gave me a weird taste in the back of my throat. All right, so as the logic currently goes, we accept an incoming connection, add them to our list of clients, create a child process, do one thing if we're the parent, do another thing if we're, or if the child rather, do another thing if we're the parent. We are the parent. All right, so right now we're calling child stuff on the if we're the child, but we're still, I mean, this will block, I suppose, we can look at it that way, keeping us from looping back up. So child stuff, as long as this guy keeps going, will block, but if child stuff ends up ending and our connected child is no longer connected, this function will then end, which will then allow this thing to stop blocking in our child process, which will then spin back up, and now one of our children will start listening for an incoming connection. Does that make sense? So right now we have these guys not separated. So we want to probably have these guys set up in such a way that the child stuff happens outside of this infinite loop. So what we'll do here is we're going to go ahead and have our int PID. It's more of a global outside of the scope of this. Inside this while loop, we'll do our PID. If PID is equal to 0, then rather than calling child stuff directly, we'll go ahead and break. That'll get us out of our loop. All right, so we'll escape this infinite loop, and then we can ask if PID is equal to 0, then we can call child stuff. All right, so only do this if we are the child and have broken out of the infinite loop. All right, so after we fork, if we're the child, we're going to bust out of here and call the child stuff. bust out and call some child stuff. This is Netflix and chill all over again. This is yeah. Ah! So there was a foot. All right. It's like, took you that long to process that, Chastity? Yeah, it was in my throat. There's child stuff going on. All right, so this is happening outside the infinite loop, and what's the parent going to go back and do? Parent's going to loop back up, sit here, and wait for another incoming connection. All right. This is because the way we had to do this here is almost kind of a side effect of what we run into with multi-processing versus multi-threading. With a thread, we would have spawned off a child thread, and that thread would have been self-contained. In this case, we're sharing the same code base between our parent and our child, and we need to effectively internally segregate the two. All right, so we're going to keep our parent trapped inside of this infinite loop for right now, and our child will escape and will compartmentalize their stuff inside of this function. And let me go ahead. I don't remember if I prototyped it, but I did. Okay. All right, so with child stuff, okay, we want to have access to the child socket that was just connected, right? Access to
You just can't.
it's literally impossible. It is literally impossible. How do you say this without
You
saying
don't name them parent and child, I think is what you do.
that's what you call them?
It's too late.
No, I know, that's like what they
Bastard
are,
slaves.
so that's like what you want to say, but the computer scientists, when
Call
they
the
were really
method
creating
something
this.
else and call it from within the child without referring to it as child stuff and parent stuff.
Yeah, but there's
We need a fundamental change in computer science away from parent-child.
No, we do.
Yeah.
We do. Otherwise, we're starting to say things like the parent needs access to the child socket, and what is that even supposed to mean?
how do you kill the child and not kill the parent?
Seriously. Oh my gosh. This is even starting to get to me, and I know chastity's already a lost case. Is this a hunting hat? What? Oh, this is just a hat with a flag on it? This is the type of stuff the people in
It's
Texas
American flag.
This is what they drive around in when they have rifles hanging outside the window. Pretty sure, actually. I think I've seen movies where the guy who's driving down the road in a pickup truck with a rifle hanging outside the window is wearing that hat.
Yeah, if you go to my hometown, it's probably like that.
Where's your hometown?
That's Stevens Point.
Okay. So just Podunk, Wisconsin?
Called Rochelle.
Yes, so Podunk, Wisconsin. I got you. So it's driving around with shotguns. So yeah. And was the hat a gift? Like, was it given to you, or did you?
Oh, no.
And you're like wearing it out of obligation, or this was like this was your style? All right, makes sense. I'm kind of feeling pretty good about the whole thing that we have a campus that doesn't allow the weapons, because he would probably conceal. He would conceal carry a rifle.
Were you at chapel this week? Oh, P. Ferry was talking about us having like an arsenal on campus.
Oh, in what context?
There's a lot of guns.
No, he was talking about signs and how people don't pay attention to them, like speed limits.
Okay,
Or
yeah.
the right turn sign.
Yeah.
Or no pets on campus.
Right.
And he was saying that with the no guns on campus, we probably have an arsenal somewhere on campus.
I gotcha. Yeah, it's probably in Chastity's room. So you would probably conceal carry a rifle if you could.
I don't think you can conceal carry a rifle.
Why? As long as it's
By
concealed.
definition of concealed carry, I don't think you'll be able to
Physically
conceal.
or legally?
Yeah.
I mean, Whitman, a rifle to live.
Yeah, I mean, it all depends on how big your pants are. I mean, during my heavy months, I could conceal carry a tank.
You could probably fit a pistol in the undersnatch, right?
That's a medical term, right?
Do you think you
Did I tell you-
Do you think you could do that?
What?
A pistol?
Oh, easily, yeah. Did I tell you about my? I don't remember when my doctor's appointment was. Did I tell you guys what my doctor said to me? I thought it was on Wednesday.
No,
Well, is that about your
That he said it was a metabolic freak show or something like that.
Yeah.
Yeah, that's not right. Just rude. I think it was a compliment though.
And then you said, "Oh, wait, I got brain tumors."
Hey, what are you gonna do?
Just gonna drop that.
You win some, you lose some, right? Yeah, they're gonna go in there with one of those. I think the same thing they use for do ice fishing. No, the ice fishing thing, the auger.
Where are they going with that?
I'm guessing they got to get to my pituitary dealy right in the center. Get in there with the auger, and then I'm guessing they're just gonna use some sandpaper.
So when's that happening?
I don't know, sometime this summer probably.
Just in case we need to send cards.
No, I think it's I don't. I'm pretty sure it's like not like normal, but I don't think they like think it's cancer. I think it's like something's pushing on my pituitary gland, which makes me messed up. So that's the thing. I get this weird eye twitch.
Not messed up then after the summer? Because that'll be weird.
No, I'll be still messed up. I might be drinking my eating my food out of a straw. But so you have to come take care of me if that's what goes down. All right. So in any case, if we are the parent, we're just going to loop back up and listen again. Otherwise, if we're the child, we'll break out of this infinite loop. We'll go ahead and call our child stuff function for no other reason. We could just put all the code in here if we wanted to, but at least this compartmentalizes it a little bit. All right. So, but child stuff needs to know about this, the client FD, the guy that was just connected, the guy that just attached. And client FD is a variable that's stored outside. Well, actually, it doesn't matter. A while loop doesn't create its own scope in any case. But we have access to that client FD that should be set to something right here inside of this. So we can go ahead and send that to our client. So for child stuff, this guy's going to take in client FD. Let me go ahead and add that to our prototype. Prototype doesn't actually need the parameters. You could just say int up here, but I usually like giving it the entire thing that way at a glance.
You want that in child stuff?
I do. I was testing you. Good job.
You didn't fail that time?
Well, Abe still did, and Chastity, of course. So yeah, in any case, you don't actually need to give it the names of your variables up here. You just have to tell it what kinds of values to expect. But since this stuff ultimately would usually go inside of a header file, which we're doing everything we can to avoid right now, just so we don't have to flip back and forth between two for no good reason other than laziness, I like to be as explicit as you can, just so you kind of know what these variables mean as you're passing stuff in. Okay, so what's child stuff going to do? Child stuff is going to take in our client FD. So we'll go ahead and pass that guy to child stuff. Child stuff receives the client FD, and we're going to go ahead and send a message. So we can get rid of this here. I'm going to go ahead and get rid of the broadcast for right now. This is when we fork. And then we're going to go ahead and after we print child stuff here, we'll go ahead and say send message. And send message is going to take in the message. Hello from a child. Do you have candy? All right. When in Rome. Okay. So, well. Yeah. And then we'll pass it to client FD. So the child will then send a message back to the client FD, and then they're going to ultimately want to receive a message. But let's just make sure this part works for. Hello from the child.
Oh, the child.
No, this is the child.
From the child. Okay. Do you have?
Yeah.
Okay. Just.
This is like. Have you ever done this before? You see, this happens on every playground where Chastity's from. You could go into. You probably don't even have Walmarts. What do they call the Hick store there?
Walmart is the best.
You don't have stores. We have a barter system. Okay, so in any case, we have our child's going to write back to the server or to the incoming connection, and they'll prove that you're receiving something from the child while the server is still listening. So we'll go ahead and compile here, rerun that. We'll go ahead and run our child connection. From his perspective, he doesn't, or the client rather, from his perspective, he doesn't care who's responding to him. Oh, yeah. That's what you were getting.
Yeah.
Yeah, riddle me that one, Batman.
Well, actually,
20 years.
I think it's how the processes are being scheduled. IO's expensive. I don't think it was able to send. It's actually interesting. I mean, it's receiving everything, but what's the client look like on the receive?
See, what,
Same
what
thing, it
happened
still
for,
splits it up. It looks like it's,
what happened for me, what ended up, by the time I finished, I would send, you know, just the, whatever, the first thing the server would send to the client would come through fine. Then I'd try and send something from the client back to the server. The server would receive it fine. It would receive exactly what I sent it, but then when it sent it back to the client, that's when I'd get the weird overwriting what's already in the buffer.
because it's redoing. It's treating it as each one of those is a separate broadcast.
Yeah, because, well, I think it's not a separate broadcast. It's a separate receive. I think it's one broadcast. We did a single send,
And it's
but it took us
receiving in chunks.
5 receives to finally get everything.
Doesn't receive take in a buffer? And don't you have to specify?
You specifies the size of it, so on the
With
chat
mine,
client,
I always sent the, we'll call it a string, hey, and on both my client and my server, I made sure that all the buffers were exactly the same size, and I didn't have that problem anymore. But you were only sending hey? Correct.
because receive, I think, tells us, what's this last, oh, here, server, this is the options. So this should be the size of server reply, which should be 2,000. That's the maximum size it can receive.
For a while, I was only getting 8. I had pretty much the exact same code, and I was getting 8 as the size of.
So you're saying over here when we're sending, string length of message, I can send in 2,000.
Oh, is it because your server reply is a pointer? It's not an actual. So you're creating the address to it. You're not getting the actual value. So it's coming back as an integer. Yeah. In the client when you're receiving.
Yeah, and we're also never actually creating memory here for this guy. Our char pointer out here, we're not using malloc. Remember last time we kind of decided that's going to be safer for us to always, where do we set it? We set it right here. We should really allocate stuff for that and then set it. All right, so let's do that on Monday. I'll give you your next assignment on Monday to take it to the next step so we can get that working and you have this new code base. So what you might do in the meantime is bring your code up to date with this in terms of compartmentalizing stuff, just so you're in a position. I think it should be pretty similar to what you already have, just probably less messy. And then we'll fix this on, yeah, I'm sure the issue is just that we created our receive thing right here, but we're sending a string that is of a, that we're trying to dynamically send a size. And I think the way it's dynamically allocating memory for it is not the way we expect it to work.
That was a problem.